Alright class, in this session we are going to continue the topic vectors. In the last class we had discussed about how to find the position of vector when the distance is due to the velocity, right? Next question number 7, it says at 12 hours our tanker sails from a point P with the position vector of 5i plus 12j. So you have the position and it's equals to 5i plus 12j. You can say that it's an initial position kilometer with respect to an origin. Tanker sails southeast. Now southeast defines the angle here, right? The angle we have it's 45 degree with a speed of 12 root 2. So now you have the speed, it's 12 under root 2 kilometers per hour. Find the velocity vector of the tanker. For the first part, we need to find out the velocity vector, and velocity vector means you need to sketch a scale here. Alright, the angle is southeast, so not this one, north, south, west, east. Southeast means that the direction is this one. That is southeast. Southeast word basically divide the angle in two parts, 45 and 45. The velocity we have it's 12 root 2. That means your hypotenuse is 12 under root 2. Alright. Now you need to find out the components. So for x component, that is your x component, right? If you need to find out this length here and we have a right angle triangle, so with the easy application of trigonometry we can find velocity of x, right? If this is your angle, so you need to apply sine this time, so it will be sine 45 is equals to opposite divided by hypotenuse, that is 12 under root 2. So find out the velocity x component. So that will be 45 sine times root 2 into 12. So it's 12. So velocity x is equals to 12. The direction is positive, so it's only 12i. Alright. But if you talk about velocity y here, that means this component, right? This component is velocity y. At first I had observed that the sign should be negative because it's in the negative y direction. Now it will be sine, not sine, at this time it will be cos. Cos 45 is equals to adjacent over hypotenuse. Sine 45 and cos 45 are same, so velocity y component is equals to 12j, but this time it will be minus 12. So the final answer for velocity is equals to 12i minus 12j, and it's kilometers per hour. Alright, that is your first part. Now you need to write down the solution in your copy and you have a time of 90 seconds, so start. Alright, for part B, find the position vector of the tanker at 14 hours and 12:45 hours. Now this 14 hours and this 12:45 hours, why it is given, you need to relate this time with respect to this one. Alright, the tanker starts at 12. What is the position at 2 hours? So that means for B part 1, the time we have it's 2 hours. From 12 to 14 it's 2 hours, right? Once you have the time, then you need to find out the position with respect to velocity. The initial position, the PI, initial position is 5i plus 12j. That is the initial position, right? We have find out the velocity for x and y. So I can say that the final position is equals to initial position plus displacement with respect to velocity. That is the working equation. Initial position is 5 and 12, it's given, plus displacement. So here we are going to apply the working formula of velocity into time equals to displacement. Velocity we had find out, it's 12I minus 12J, and time is 2 hours as I mentioned earlier. Now you need to solve this equation here. So it's 5, 12 plus 24 minus 24. 5 plus 24 leads to 29I, plus minus 12 minus 24 minus 12J. That is the final position of tanker after 2 hours. Alright, so I hope that this is clear to you. And you need to write down the solution in your copy. For this part we have a time of 60 seconds, so start. Alright, after that part C. Now part C and part B are very much similar, only the difference is that, firstly I need to attempt part 2 here. Alright, so I think part 2 you can do it by yourself. Alright, so you need to give it a try by yourself. So you have a time of 1.5 minutes, right, to attend part B, so start. Alright class, now the main thing in part 2 is about the time. Starting from 12 till 12:45, that means now the time we have it's 45 minutes, right? But we cannot use this time because we are using the units hours. So here you need to convert your time minutes into hours, that will be divided by 60. So 45 divided by 60 leads to 45 divided by 60, it's 0.75. So now the time is 0.75 hours. Alright, so that is your time, and now the question will be very much similar, that we need to find out the final position, and I'm going to use this equation here. So final position is initial position, that is 5 and 12, plus speed is 12 and minus 12, but this time the time value is 0.75. Alright, now simplify it, so that will be very simple. 5 and 12 for the position, plus 12 times 0.75 gives you the value of 9. So it's 9 and minus 9. Alright, so 5 plus 9, it's 14I, plus 12 minus 9, it's 3J. That is your final position for part 2. That is your answer. Alright, after that C part. C part is very much similar to B part, only the difference is instead of the value of time, it's only written T hours. So how you are going to do that? It will be final position is equal to, the initial position is same, that is 5 and 12. The velocity value is same, that is 12 and minus 12, but this time the time we have, it's T. Alright, so you need to leave your answer in this form, and whatever the value of time you need to place instead of T, and you will get the final position. So that expression is the answer for C part. Alright, moving on towards the next question. Next question number 9. At 15 hours, our submarine departs from point A and travels a distance of 120 km to a point B. The position vector R of the submarine with respect to an origin T hours after 15 is given by this. Write down the position vector of the point A. Alright. So firstly, it says that at 15 hours, a submarine departs from point A and travels a distance of 120 km to a point B. So you have the value for distance. The position vector R kilometer. Now what is r? We don't know. With respect to an origin is given by, so you have position of r in with respect to time here. So you need to find out the position vector of A. Alright, A is basically the initial position, right? If you focus your r vector here, so it's 15 plus 8t and 20 plus 60. Now we have attempted previously question, so we know that this part is basically the displacement with respect to velocity, right? Velocity and time, it will be displacement. So the initial position, it will be this part only, right? Initial position, it will be this part. So for first part, position vector of point A, I can say that the position vector is 15i plus 20j. That is the initial position of submarine. Alright. For part B, when it says velocity vector, so we had discussed that this displacement is because of velocity, right? The velocity vector of the submarine, and in the question says that our submarine with respect to an origin TR is given by this. So this position is with respect to velocity, right? So I can say that the velocity component is 8i because of 80 plus 6j because of 60. So that is the velocity component which you had multiplied with the time to find out the displacement. So that is your part B answer. In last part, it says find the position vector of point B. Alright. So for position vector, we have the initial position find in the first part, right? We have the velocity in the second part. Alright. So basically, what I need to do, it's given r is equals to 15 plus 80 and 20 plus 60. What I need to do, I need to find out the value of time here. How you are going to find this one? It's very simple. How? In the second part, we had find out the velocity, right? That is 8i plus 6j. If I have the value of velocity, that is 8i plus 6j, I need to find out the magnitude. Alright? So magnitude, it will be under root of 8 squared 64, 6 squared 36, 100, and it will be 10. That is the magnitude of velocity, right? Displacement is given in the question and it's 120 kilometers, right? So now it's very easy for me to find out the value of time here. So time is what? Displacement over velocity means 120 divided by 10 is equal to 12, and 12 is your time. Alright, now we have the expression for r and we need to place the value here. R is equals to 15 plus 8 times 12, 20 plus 6 times 12. So 8 12s are 96 plus 15, it's 111 I plus 12 into 6, 72 plus 20, it's 92 J. That is your final answer for last part. Alright, so before proceeding to the next question, you need to write down the solution in your copy, and you have a time of 4 minutes to write down all the solutions this time. Alright, it's question number 11. At time t equals to 0, boat P leaves the origin and travels with a velocity of 3i plus 4g. So you know that at time equals to 0, velocity we have it's 3i plus 4j. Also time t equals to 0, boat Q leaves the point with the position vector of minus 10. Alright, so that is the velocity of P. Alright, and at time equals to 0, the position vector of Q is equals to minus 10i plus 17j and travel with the velocity of, so you have the velocity of q which is 5I plus 2j. Write down the position vector of boats A and B after 2 hours. So now for the first part, we know that the value of time is 2 after 2 hours. You need to find out the position vector of boat A and boat B. Alright, so first give it a try, think about the possibilities of this question, and you have a time of 2 minutes only for the thinking part, and then I will start to begin. Alright, so firstly, if we talk about the position of Q, alright, for Q, starting with the P, alright. First, if you talk about P here, so the position of P, it clearly mentioned it leaves the origin, right? That means the starting point is 0, 0. And the only displacement is due to the displacement of velocity. So firstly, I am going to write down the heading here, position of P. Alright, so the starting position is origin, that means 0 and 0. And the distance traveled is the only distance that is traveled by the velocity and time. The velocity we have, it's 3 and 4, and the time is 2 hours. So for P, the position vector, it will be 2 3s are 6I plus 8j. That is the position of P. Alright, similarly, if you need to find out the position of Q, now, Q is basically having the position vector and the velocity as well. So the procedure is very much similar like we have done in the previous question. The position is what? Minus 10, 17, and the displacement with respect to velocity is 5, 2, and you need to multiply it by time. Alright, it's easy to solve this one. So minus 10, 17, if you multiply, it will be 5 2s are 10, 2 2s are 4, add them, minus 10 plus 10, it's 0I, 17 plus 4, it's 21j, that is the position vector of Q. Alright, so I hope that all of you are clear in the position vector of P and Q. That is your first part answer. For the next one, for part B, it says find the distance between boats P and Q when t equals to 2. So you have a time of 2 minutes to give it a try by yourself, and then I will tell you the answer. So start. At first, I will find the expression. So distance between P and Q, it's PQ minus position of P. All right. PQ is what? It's 21j minus 6I minus 8j. Alright, that will be 21 minus 8. 21 minus 8, it's 13j minus 6I. That is the position of between A and B, distance between A and B. Alright, we need to find out the value. So you need to find out the magnitude. That means it's minus 6 square plus 13 square and then root on it. Alright, so 13 square is 169 plus 36 and root of it, so that is equals to 14.3. Unit is what? Kilometers, because it's a distance. Alright, and that is your final answer. Alright class, I hope that it is clear to you. So what we have discussed so far, we had learned that how to find out the final position if you have the initial coordinates and you have a velocity and time values. Velocity and time leads us to find out the displacement, and that displacement when we add in the initial position, so we get the final position of that particular vector. Alright, as a homework, what you need to do, you need to attempt question number 6 of the same exercise, and for your convenience I will paste question number 6 here, so that will be very easy for you to search out the question. Alright, so that part is your homework. You need to attempt all 4 parts, and also I will paste answers here so you can verify your answer once you are done with the solution. And if there is something you are not getting it, so don't hesitate to drop me the message on the portal. Alright, so I think that is quite enough for today class. We had discussed about the basic thing of vector, and this portion basically covers in relative velocity, but that chapter has been eliminated from your CI syllabus. So now we are going to cover that time velocity displacement portion in the vectors, and this part will only include the complicated part. The complicated topic has been eliminated. Alright, so I hope that all of you have a clear idea how to solve vectors, how to find the position vectors when you have position and velocity time given. So inshallah in next class we are going to continue with the same topic. Till then you need to practice, you need to attempt your homework, and if is there anything that you cannot clear about, then ask me and I will try my best to reach you as early as possible. Alright class.